Welcome to English for Professional Mechanical Engineers. My name is Jun Tu. I'm happy to have this chance to speak to you today about computer-aided engineering, CAE. In today's lesson, we are going to introduce the third section of CAE, Structural Analysis 1. Structural analysis is the determination of the effect of load on physical structure and their components. Structures subject to this type of analysis include all of that must withstand loads, such as building, bridges, vehicles, machinery, furniture, attire, soil strata, processes, and biological tissue. Structural analysis employs the field of applied mechanics, material science, and applied mathematics to compute structural deformations, internal forces, stresses, support reactions, acceleration, and stability. The results of the analysis are used to verify the structure's fitness for use, often precluding physical tasks. Structural analysis is thus a key part of the engineering design of structures. Hierarchical modeling means taking increasingly more complex models to simulate nature with increasing accuracy. In this sequence, we make several assumptions regarding the geometry and the physical effects, such as spring, rod, truss, beam, shaft, frame. In two-dimensional solid, plate, shear goes to fully three-dimensional solid. Dynamics effect, nonlinear effect, and so on. In this lecture, we will focus on structure that could be presented by 9 models. A truss is an engineered structure consisting of straight members connected at their end by means of bolt, rivet, pins, or welding. The members found in trusses may consist of steel or aluminum tubes, wooden strut, metal bar, angles, and channels. Trusses offer practical solutions to many structural problems in engineering, such as power transmission towers, bridge, and the roofs of buildings. Members of a truss are generally considered to be 2/4 members. Besides, steel columns are commonly used to support load for various floors of multiple-story buildings. Beams play significant roles in many engineering applications, including buildings, bridges, automobiles, and airplane structures. A beam is defined as a structural member whose cross-sectional dimensions are relatively small than its length. Beams are commonly subject to transverse loading, which is a type of loading creates bending in the beam. Frames present structural members that may be rigidly connected by welded joint or bolted joint. For such a structure, in addition to rotation and lateral displacement, we also need to be concerned about axial deformations. The procedural structural analysis of CAE includes select an analysis system, create geometry, prepare engineering data, material, develop a model, assign material, general finite element mesh, set up boundary condition for support and load, solve for the analysis, and finally view the result, including deformation and stress. For a case study, planar trusses. Members of trusses are made of aluminum alloy with cross-sectional area of 15 centimeters square, as shown in the figure below. Please find the deflection of each joint and the stress of each rod and the reaction. Start the application package of CAE, for example, ANSYS. In the lab toolbox, select static structure from the analysis system by double-clicking. To create a geometry model, double-click A3 Geometry to enter the design model. Draw the 4 members of the truss by 9 or polyline, and then create 9 bodies. Select the option of cross-section rectangular. In the details of rectangular, modify the value of width and the height so that the cross-sectional area is 15 centimeters square. To prepare material properties, in the project schematic, select A2, Engineering Data, press the right mouse and pick Edit. In the engineering data, add aluminum alloy for later use. To develop an analysis model, double-click A4 Model. In the model tree, expand Geometry. Select the 9 bodies. In the bottom details, change the material assignment from structural steel to aluminum alloy. To generate final element mesh, select the option of Mesh. Press the right mouse and click Generation Mesh. To apply boundary condition for support and load, in the model tree, select static structure. In the top toolbox, press Support and pick up Simply Supported for left 2 nodes. In the top toolbox, press Load and pick Force. Select the top right node. Press Apply in the detail for geometry selection. Define by component and set Y component as minus 2000 Newton. In the model tree, select Solution to set up the desired quantity, including total deformation, directional deformation, stresses, and the force reaction. In the top toolbox, press Solve. After a few seconds, the solving process is completed. Select the preset total deformation to view the deformed body. Select the directional deformation to view the y-axis or vertical deformation. Select the direct stress to see members of the truss in tension or compression. Select force reaction to find out the reaction at the support. Do all the results make sense? Finally, we prepare some questions for you. Question 1. For the following structures, whose members are generally considered to be two force members? A. Truss. B. Beam. C. Frame. And D. Plate. Yes, the answer is A. Truss. Question 2. Which type of the following structure is commonly subject to transverse loading that creates bending? A. Truss. B. Beam. C. Frame. D. Plate. The answer is B. Beam. This is the end of this session. Structural Analysis 1. I will see you again in next video. Goodbye.